this has already made me a little bit hungry because I got up at 5. So, but we have, as the keynote speaker, somebody who wrote cookbooks, I hear.
I did, yeah. But I guess not the kind of cookbook.
So what are they about?
They're about programming. I wrote a book called the TypeScript Cookbook, a couple of others, so yeah, mostly programming stuff.
So they're all about the same language?
Yeah, JavaScript, TypeScript, yeah.
But that nutritionally is not very diverse.
No, it's not very healthy. So I mean, there's a lot of fiber in those books, but but I don't think they will do well.
All right. Well, I am really interested in the heroics of failing successfully. Let's give it up for Stefan Baumgartner, our first keynote speaker.
Cool. Good morning. All right. Good morning, everyone, and good morning to the folks. Where's the camera in room 6? Hi. Thank you for being up so early to join my little talk, my little story that I have to tell. But hey, how do we start this? Have you ever wondered how some things ended up in places where you wouldn't expect them to end up? Well, I have a little confession to make. I don't know how I ended up here. Because I don't know jack shit about Kubernetes. I'm very sorry about that. So if you want to ask me any Kubernetes-specific questions, I couldn't answer them. But wait, I have been part of a Kubernetes-based product at Dynatrace, and I want to tell you a couple of stories from how things went down from, let's say, an outsider's perspective. This is the product. This is the current generation of our observability and monitoring platform. Don't worry, I don't bother you with product shit now. This is just for context. And I say platform because I mean it, because we at Dynatrace went through a couple of software styles with monoliths, with microservices, and we found that given the size of our company, it's really hard for those teams to maintain a single piece of software. So we split up the monolith in little tiny apps that teams can develop on their own. And this is where you see one of those apps. So there's the application frame, and in the center is the app. And this is what it schematically looks like. So we have the Dynatrace platform as a strong foundation. And on top of it, we have lots of services like settings, documents, which is kind of a file system. You can send mails. You have application state, stuff like that as a layer of strong, quote-unquote, microservices. And on top of that, you have small apps, like our main cores, like dashboards, notebooks that drive Dynatrace, but also smaller apps without an UI that basically connect you to AWS or whatever. So we took platform engineering, literally, we engineered a platform. That's what we did. And if you know this beautiful meme of the difference between monolith and microservices, we went full ahead. So apps are basically the add-on of it. And I like it because there's some truth in this image. If something turns bad, what's easier to clean? So I think it's quite fitting. So what is an app? An app consists of 3 parts. There's static assets like images, stuff like that. There's front-end code, statically served JavaScript and CSS, sandboxed in the browser. We use iframes for that to create a proper sandbox so no things leak out. And then we have this one here, and this is what I want to talk about. We have backend JavaScript. We want our developers to write backend JavaScript code if they need to have backend. And in doing so, we want it to be serverless for a couple of reasons. So quick show of hands. Who has developed serverless applications in here? All right, a couple. One reason was the ease of development. You just add the one piece of functionality that you need. And the other fact was maybe having a billable unit, invocations. So in serverless, you don't pay for how long is the server up. Yeah, you actually do, but you pay for the time it takes an invocation to finish. And since we open up our platform not only for our employees and for our developers, but for customers and partners, it's good to have this particular unit available. First, it's tangible and we know how apps are used. And well, with serverless, it's okay to deploy an app and not run it. That's very necessary. All right, let's see how we started out. Have you heard about the not invented here fallacy? Quick show of hands? Yeah, cool. It says that folks tend to do everything on their own because they don't trust stuff written by others. And this is something that we took ourselves to heart. So we wanted to avoid that fallacy, and we started out looking at all available open source serverless solutions that there are. OpenWhisk, OpenFast, Knative, you name them, even all those POC WebAssembly stuff, like I even forgot how Crustlet, I forgot how it was called. We tried all of them, and unfortunately, none of them were usable in a way we needed it, given the scales of how many people we wanted to have on those platforms. I don't bore you with those details, but what we found out is that they are not necessarily bad, but those are solutions that have been developed for a specific use case, and this use case was not ours. Our use case was to run potentially untrusted code from basically anybody in a high-risk environment where you have actual crucial data that they need to access. And this is an environment where we can't control what's being executed. And our serverless platform not only needs to run well, but it also needs to fail well. So we started out early asking ourselves, how well does it fail? Which led us to AWS Lambda. AWS Lambda is probably the most prominent of the serverless solutions. And this is not the Lambda logo. This is the Half-Life logo. But I like how it's being used anywhere. So I'm sure you know that. So what's the one particular special feature about AWS Lambda that basically no other system has, to my knowledge? And this is isolation. So invocations in Lambda work like that. A trigger sends an event. The cold start phase happens, the micro VM boots up, it creates an environment with your code in it, and then you have your execution handler, it pulls stuff from the queue, works, and pushes back the result. And then again, and again, and again, and again. If a second request happens, a second trigger happens, you get a brand new micro VM where this code runs again. So every process, no matter which technology you use, is isolated per invocation in a virtual machine. And this is the one thing that I think is different to any other solution. If something fails, if you have an error of whatever reason, then the VM crashes and it's booted again. Fantastic. There's no influence on any of those other invocations happening. You don't have noisy neighbors. If something crashes, it's fine. It's even better to let it crash than to have some idle state that you don't know what's happening. So from that perspective on, perfect. And if you don't run it, well, then it's getting disposed and the resources become free. So for our case, where we knew that we run code from potentially anybody, this was perfect. We had perfect resource handling. Lambda allowed us to handle and constrain those resources really, really well. And since every invocation gets its own instance, you don't have any issues with noisy neighbors or broken code or even crashes. In fact, it's preferred to crash before it goes into a state that's hard to recover. So yeah, this fails well. If we ask ourselves, how well does it fail? This fails really, really well. This has been designed for failure. All right, with that out of the way, we were good, we were running apps, we were deploying apps. Every app was a Lambda, and we just had, no noisy neighbors, and we were just running them when needed. It was economically fantastic, and for our needs, the perfect solution. But the challenge didn't stop here. So after we decided on a way how to run and deploy our apps on the backend, we got a new and frankly very exciting but also very scary use case, which we dubbed ad hoc functions. This is another part of our product, the workflow engine, where you can design automations with different steps, etc., and you follow through them. And if you look here closely, I mean, it's a big screen, you can see it. There's a little text there that says, run JavaScript. What does this little button mean? This little button means that everyone can run any JavaScript written in the browser on the backend. Again, everyone can run any JavaScript written in the browser on the backend. Or let me emphasize it differently. Everyone can write any JavaScript in the browser to run it on the backend. I don't know about you. I don't know who of you has worked in JavaScript. Yeah, all right. I don't trust my JavaScript skills. I've written 3 books on them, and I still don't trust it. And knowing that it's so easy to open up an editor in the browser, let them write JavaScript and execute it somewhere on the backend, this gives me goosebumps, not the good kind. So we needed to wrap it up nicely. We needed to isolate it a little bit more than it was possible before. And thankfully, there's in Node.js, which was our technology of choice, there was a way to do it. And this way was called the VM package. I don't know how much you know about Node.js and how it's designed, but you have V8, the Google JavaScript engine, and you can create different virtual machine contexts inside there, which allow you to define some globals, global symbols. You have a context that is different from all those others, so there's no possibility to swap contexts while executing the code. And we have been already using that to abstract a few things when we wanted our folks to write JavaScript on the backend. So yeah, that's pretty good actually. And we used it and we tried to adapt it for ad hoc functions, and then again we asked ourselves, how well does it fail? So it worked good, but how well does it fail? Yeah, honestly pretty bad. So it even says in the documentation, and you maybe have seen it on the earlier slide as well, it says, this module is not a security mechanism. Don't use it to run untrusted code, which we do. So yeah, they're right, this is not the right technology for it. Even if it works well, it's just so easy to bypass the sandbox. So the first line up there, this is fantastic. Even if you have everything nicely isolated with the symbols you provide, with the first line you can break the sandbox and run any shell code on your virtual machine. This here will just basically return the process, and then I call exit, which means I shut down the entire Node.js process, which takes a little while to recover, but I can execute any bash scripts there. I can access the entire environment. I can do really, really nasty stuff. The other line basically overrides the console log statement with your own console log, which allows you to do stuff in between, where you can, I don't know, send sensitive data to, I don't know where. And if you have written JavaScript, you know that console log is your prime debugger. So people are using that. You don't want to override that. And then you have AWS Lambda as execution environment, which means that if I open up the browser and I write the second part, I send it over to the backend, it ends up in any virtual machine. I don't know which one. Go find that bug. It's atrocious. Thankfully, there's a remedy for that, which is the VM2 package. The VM2 package states VM2 is a sandbox that can run untrusted code. Securely, exclamation mark. So why not use that? So we did, but I mean, I kind of gave it away by showing you the Sneak website and not the NPM website for that. Those are the high-risk security bugs of the VM2 package, including sandbox bypass and other vulnerabilities that haven't been fixed since 2023. So yeah, cool idea. Execution, not so much. Also not good for the stuff that we wanted to do. So for us, it was just too easy to bypass anything and break out of it. And again, if anybody can write any code inside the browser that ends up in our execution environments, this is incredibly risky. So it failed really well. This is why we decided, and this is potentially up for debate how good of an idea that was, we designed our own JavaScript runtime. So instead of using one off the shelves and running it on AWS Lambda, we invented, quote unquote, our own, which we dubbed Oni.js. I don't know if the Dynatracers in the room know that already. Here, we dubbed it Oni.js. And it's based on V8, just like the other one, and Deno, the Rust-written JavaScript runtime that has been released a couple of years ago. But it's tailored for our needs. So even if you use that core and the strong foundation, we changed it significantly to be much, much more secure for that kind of scenarios that we wanted to write. We've been running it now for 3 years, I guess, constantly, with millions of invocations a day, and we never had a security problem with it, nor did we have any other problem with it. And it has a couple of features that distinguish it from others. The first one is pathfinding, which is, I think, pretty cool. Every URL that you call will be extended. If it starts with a slash, it will be extended to a platform URL, which makes it very, very easy to develop, like you would in the browser or like you would in the server where everything is combined with each other. And the pathfinding system just finds its way to the right URL, if necessary. This also includes an allow list, which means that if you're not supposed to call, I don't know, maliciousURL.com or something similar, you can't because it's not allow listed. So if you need to call external stuff, you need to exclusively allow list it. Extra security. And the other one, which I find quite interesting, is that since we can create VM contexts on the fly, and they only take a couple of milliseconds, we recreated the entire sandboxing process of AWS Lambda again. So where AWS Lambda creates a sandbox, downloads code, bootstraps it, and runs it, we already have a sandboxed Lambda where our runtime is, and then we load just the JavaScript file that we want to execute from the disk. We bootstrap the global symbols in the VM context and run that, which allows us to get rid of the connection between apps and Lambdas. We just have runtimes now, and they can execute any code because it's extra secure. And this bootstrapping of that code takes mere milliseconds, being immensely fast. So where Lambda has a bootstrapping process that is heavy, ours is fantastically lightweight. And with that comes another security feature. Since it's so lightweight to run, we can just throw away the execution after it happens. We don't need to have any warm VMs. We can afford a cold start because it just takes a couple of milliseconds. And this is what we do with every invocation that you do. We create a new VM context in our demo runtime, in our OnlyJS runtime, there I have it, and start fresh. At the end of the execution, we throw everything away. No remnants, no memory leaks, no symbols that have been overwritten. Nothing stays. You start fresh, and you don't feel the tax that we pay for it because it's so small. So yeah, if anything goes wrong, if you have a security breach or whatever that we don't know of, it fails really well because after the execution, we just throw anything away and start fresh. All right. We knew our serverless executor. We know our runtime now. The next challenge, going multi-cloud. So I spoke about AWS a lot, and it was good that we said, okay, at the beginning, let's go with AWS because it takes care of a lot of problems that we faced. It was the right technology for our problem, and Lambda was fantastic for our case. But we needed to go to other hyperscalers as well. Some folks don't want to be at AWS, so you need to support Azure, Google Cloud, you name it. And obviously they are the same, aren't they? Well, I guess there's a talk today later on that tells you that they aren't the same, and I suggest you watch it because you're going to hear a couple of fun stories. But the serverless offerings are the same, aren't they? I mean, look at it. That's 3 Hello World calls from those 3 different hyperscalers like Google Cloud Functions, Azure Functions, and AWS Lambda. And they kind of look the same. So you have some difference in how you export that stuff, but if you tilt your head and squint a little bit, it's the same code. And I'm pretty sure you can find a layer that, I don't know, combines all of them. So that's Azure Functions, Google Cloud Function, AWS Lambda. Who would have guessed? Who knew that? Show of hands. Nobody? You? 2. Yeah? Well, that's interesting because I tricked you. It's actually AWS Lambda, Azure Functions, Google Cloud Functions in that order. And I totally understand that this is incredibly confusing. And to me, it happens all the time that I mix them up. It's hard to tell. It really looks the same. And development-wise, it's also very, very similar. Don't get me wrong. If you just develop Azure Functions, Google Cloud Functions, or AWS Lambda, it feels very, very similar when you develop it. But we don't want to have it in Node, and we don't want to run it with with the built-in Node.js runtimes, we want to have our own runtime that's immensely secure running on Azure Functions. So here's a quick tutorial on how we can write a custom runtime for Azure Functions. Step 1, we configure Azure Functions for a custom handler. Step 2, we enable HTTP forwarding. And step 3, we map our endpoints to those of our custom server. Wait a second, server. Did I see that right? Did you see that right? I thought we are in a serverless environment. What's the server doing here? Well, it turns out that Azure Functions is not really serverless. It actually runs servers, lots of them. And that's how the whole deployment model is designed. You have this function host. This is the only thing that's actually the common core of all those variations that you have. It has a repurposed webhooks runtime. When you write your C# code or your F# code, it can compile it as a DLL and load it and run it inside the same process. If you want to write Node or Python or Java or Go for that matter, you need to have an out-of-process runtime that they provide, which communicates via gRPC. And then the stuff that we did, because we've written our runtime in Rust, was calling it via HTTP. And then you just spin up any HTTP server, you take up the endpoint, and you execute your stuff. So, I mean, from a development point of view, that doesn't matter. But from an execution point of view, you're not having one single invocation at a time. You have all invocations at the same time, running on the same process. And how they are scaled out, because you have auto-scaling with Azure Functions, you don't know. That's hidden from you, and that's stuff that are Azure Functions internals. And I'm not saying that this is bad by any means. It's just not what we expected. Azure Functions focuses a lot on the serverless development model. How do you write your functions? How do you deploy them? What's your developer experience doing that? It focuses not so much on the serverless infrastructure part, where you say you don't have any servers. You have ephemeral tasks that spin up, go down, and being dropped. Which means, how does it work with noisy neighbors? How does it work with stuff that takes a long time to execute? It might work. We tried it. We saw how well it failed. It didn't fail well. So this is a Gatling test running our runtime on Azure Functions. And the first one is a simple hello world. That's the top left corner, which, you know, with increased calls, you end up in a couple of those that can't be answered. But the moment you have stuff like CPU hogs or memory hogs, where we allocate lots of memory or where we use lots of CPU, things go down really, really bad. CPU hogs are interesting in JavaScript because most of the time when you write JavaScript, you wait for stuff. You're doing a fetch call, an HTTP call, you wait for the response. When you write in the browser, you wait for user input. So JavaScript is really, really good at waiting, which is interesting because everybody develops faster JavaScript runtimes, which means, oh yeah, I can now wait faster. But if you really need CPU power, you fill up the whole process, and it needs it until it's being done. In total, just around 30%, 33% went through from the Hello World cases. The moment we did anything reasonable, stuff broke down. This was devastating. So we had high hopes, but understanding that we're actually running servers again. And if you don't run a JavaScript server asynchronously with the built-in mechanisms, you fail with this deployment model. And since it's a server, everything that you run on it, which takes up resources, influences all the other invocations as well. And sometimes even across VMs if you have a shared pool of resources that you need to do. And I don't know, this is not necessarily bad, it's just a different focus. Azure Functions focused on different things than we had a need for it. Just like this artist. I don't know if you know this image or if you have seen it. Can anybody guess what it is? It's a knight with a big bushy beard on a friendly dragon. And he battles some fierce monsters, and there's a castle in the background. Anybody, any idea what it is? Maybe you know the Japanese version. It's actually a strategy guide, a German strategy guide for Super Mario World. And once you see it next to each other, you see the similarities. But the designer obviously focused on something entirely different. It's not wrong. It's maybe just not that focus that you expected. Which led us to the last piece of our puzzle, Kappa. So if you think about our journey so far, changing the runtime into something that we've written our own, based on that serverless model that we needed from AWS Lambda, we managed to do the same thing that AWS Lambda does inside the virtual machine, inside the V8 VM context. We were able to isolate it even more. We had lots of similarities in how we isolate our runtime and how AWS Lambda isolates micro VMs. So everything that we could do with AWS Lambda, we can already do in the runtime, except for CPU throttling and memory management. That's the only thing that we needed. We needed a place to run it that limits CPU and limits memory. And I guess all of you in here know where this ends up. This is Kappa. Kappa is our Kubernetes-based serverless platform that we've written. It's Kappa because it's close to Lambda, and it starts with a K, because Kubernetes, and that's cute. And we have also a pretty cool logo for it. And it's really simple. So we have a couple of runtime worker pods. They are all the same. They are stateless because they take any function and can execute it. This is what we designed. And then we have a RabbitMQ queue in front of it where you can pull down tasks and execute it. And then you put up the results again, just like you would do with Lambda. Some very smart folks in our company have designed this Kubernetes cluster to be as flexible as possible. It has elastic CPU. It just grabs the CPU it can, then it goes down again. Scaling, whatever. They did fantastic stuff in there, and this is exactly the part where I can't tell you the details because I don't know them. But if we ask ourselves how well it fails, look at that. It's the same workload with the same tasks running on our Kubernetes environment, running on Kappa. And we have a failure rate of 1%, and this is actually some scaling stuff that we already tackled. So for this test setup, I would say it fails fantastically well. All right, to close it down. One thing that is interesting is that we started out trying to avoid the not invented here fallacy. We didn't want to use anything that has been we didn't want to invent everything on our own. We ended up inventing everything. We started with the runtime. This was our thing. We have now our own serverless platform. The only thing that we didn't invent ourselves was the message queue. And since this is the only thing that gives us headaches at the moment, I guess it's just a matter of time. But you know, this is not something that happened overnight. This was a process. This was evolution. Every decision that we made, every tool that we have exchanged led us to this better product that we have right now. And one very interesting thing is that even if we developed all those things on our own, we are not the only one. And you, when you develop something, you are also not the only one. In recent years, even months, we have seen efforts, for example, by AWS to develop a runtime that is, in certain features, very, very similar to ours. This is the low-level, the low-latency runtime, written in Rust, bindings to C, JavaScript engine, which also throws away everything after the execution and starts it anew, because it can afford this cold start for added security. There's companies like Vercel who have also this Rust binding to their VM that we have, where they can do things like pathfinding, just the same thing. And I'm pretty sure the stuff that we did with Kappa will also come up by somebody else at some point in time. And this is okay, because it's only natural that every one of us struggles with the same problems. And everybody fails at some point and has the need to improve the software. And this is what this little story was all about. So today, at this conference, you're going to see a plethora of excellent talks. And I'm very happy to see that the folks, the organizers who were in the program committee, focused those talks on a lot of first-hand experience reports. Those are the people who tell you exactly what has failed and how they overcome it. Because if everything would have went smooth, there would be no stories to tell. So sharing this knowledge is absolutely priceless, and I invite you to watch as many talks as you can, and if you have the time to talk to the speakers and ask, hey, what's your war story? What has failed? What went horribly wrong? And you have two results then, either they smile and tell you the story, or they frown and tell you the story, but you're going to hear some very, very interesting stuff. With that, I want everyone to have a fantastic conference. I'm very happy and I'm very honored to open up the Kubernetes Communities Austria for you. Thank you very much.
What a fantastic lessons learned here. I mean, so many things about heroes and anti-heroes. First of all, thanks for making this event a treat.
Oh, cool.
And so we don't have times for questions right now, but as Stefan said, the most important things are the interactions with people when they talk about what really happened, right? So please take the chance to also, you're going to be around for the conference?
I will be around until 1-ish, 2-ish. So going by train currently is a nightmare. And I need to be at home in the evening, so I will take an earlier train possibly. Yeah.
But please take the opportunity to talk to Stefan. Thank you again so much. I have so many questions that I want to pick on. A huge applause again for Stefan Baumgartner.
Thank you.